Hi, I'm Tracy Lauderette, call sign Jackie O, Colorado's First Lady Fighter Pilot. We're here at Wings Over the Rockies Air and Space Museum in Denver, Colorado. We're getting an inside look at the International Space Station.
The ISS is this amazing orbital laboratory flying around the Earth at 17,500 miles an hour.
It takes a city to send somebody to space.
Right at its very inception, it barely survived a vote of confidence. It was just too complicated, it was too expensive.
This is a vehicle that has brought countries together to accomplish something just enormously difficult.
The space station assembly is by far the most complex thing we've ever done. Once you get up there, there's no turning back.
The grand adventure of exploration is just one of those things inside of us that will never stop.
Our next steps on the moon, sending humans finally to Mars. We've laid the groundwork for all of that.
It's time to go behind the wings. "250 miles above our heads, an unprecedented feat of engineering is orbiting the Earth. It's continuously housed astronauts since 2000 and conducted more than 3,000 experiments. This is the International Space Station, a partnership of 15 nations, a symbol of peace during times of tension, and the longest continuously inhabited structure off Earth. Bill Spetch has been part of the space station team for 27 years and is currently responsible for operation management.
We are doing the science, the engineering demonstration, the technology demonstration that really enables us to better life on Earth and allowing us in the future to go to Mars. And it really provides this amazing microgravity platform for all of the nations of the International Space Station to participate in and really learn about how we live and work together in space.
I showed up at NASA in 1995.
Steve Lindsay is a former astronaut, a 30-year NASA veteran who's flown on 5 space shuttle missions and logged over 1,500 hours in space.
I was fortunate enough to be at NASA during the entire time of the assembly of Space Station from start to finish. The vision for Space Station was to basically really learn how to live and work in space. We'd done, Mercury, Gemini, Apollo, shuttle missions, all short duration stuff. What we wanted is a facility where you could do long duration studies, not just on the science, but also on the people. How do they handle a year in space? What happens to their bodies? What are the physiological changes? Can we survive on, say, a long trip to Mars, which is like a 3-year mission?
The quest to inhabit space took flight in the 20th century. What began as a bold vision has become an ongoing mission. At NASA's Johnson Space Center, historian John Urey chronicles the space station's evolution. John, take us back to the beginning.
First proposal for a space station actually goes back to 1883. A Russian scientist named Konstantin Tsiolkovsky proposed a space station. He even made a drawing of it, of people floating weightless in this space station. NASA began studies in the late 50s of a space station, but in 1961, President Kennedy said, no, we're going to the moon.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
So space station took a back seat. So it took until the Reagan administration in 1984 when he said, NASA, please build us a space station and do it within the decade. I think he was trying to channel JFK there.
The space age is barely a quarter of a century old, but already we've pushed civilization forward with our advances in science and technology. Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
And that's how the space station started, but that still wasn't the International Space Station. It went through multiple iterations of redesigns because it was just too complicated, it was too expensive.
Prohibitive cost inspired an audacious question. What if the next great leap in space wasn't a US mission, but a global one?
Can we do that sort of thing? And we wanted to learn more about that. Exploration is too expensive and too complex for one nation to go it alone. So we wanted to develop partnerships, figure out how to work together with a multitude of nations and make this happen.
Then we invited international partners to participate. The Europeans, the Japanese, and the Canadians, they all showed great interest because they didn't have space programs of their own. This way they could hitch a ride with NASA and do science on orbit.
Without those partnerships, I don't think we would have been able to build a space station economically, politically, and otherwise.
We signed agreements with all the partners. President Reagan gave it a name. He called it Freedom. The Russians had already started their space station Mir, which means peace, so that we would have peace and freedom in orbit.
The U.S. now had partners, but still needed know-how, and Russia held the answers we needed.
They have lots of experience flying space stations. All we had at that point was Skylab in the 1970s, which flew for less than a year, very successful, but not a lot of experience. And that's how International Space Station was born. And so finally, after the collapse of the Soviet Union, President Clinton came along and said, let's invite the Russians, we'll join forces.
An important first step toward full Russian partnership in what must be our next great mission, the International Space Station.
The first thing we did with Russia we called Phase 1, and that was the Mir space station, where we put US astronauts on the Mir space station for long duration stints so that we could get experience in long duration flight. And at the same time, we started developing the space station that's in its current form today.
The next challenge was to build a training program for a very specific task, spacewalks. To construct the space station piece by piece would require hundreds of hours of work on the spacecraft's exterior, work known as extravehicular activity, or EVAs. Critical experience that US astronauts just didn't have.
We needed more spacewalk experience to get ready for this wall of EVAs or we'd never make it through it. We have to learn how to operate in space in a zero-G environment. But how do we simulate that on the ground? The closest thing you can get to space is neutral buoyancy. We figured out by training underwater, you could simulate zero gravity about as close as possible.
NASA customized a facility to prepare astronauts for spacewalk training, the Neutral Buoyancy Lab in Houston, Texas.
The Neutral Buoyancy Lab, which is code for a really large pool, it's about 100 feet long and is 40 feet deep all the way across. And we have the entire space station underwater in that facility. The NBL was built specifically for the space station because it was so large. Absolutely critical. I don't think we could have built space station without the NBL.
This 6.2 million gallon pool simulates weightlessness. It's where crews rehearse spacewalks, practice maintenance, and train for every imaginable contingency.
Here we weigh out the astronauts to be neutrally buoyant no matter where they are in the water column, and that helps simulate that microgravity that we have on the space station. So you're going to see today astronauts actually getting in full-blown spacesuits. They do their actual missions they would do on the space station.
We put on a very close to space flight suit. It's almost exactly the same. And when we get in the water, we're floating like we are in space. It really helps us to feel like we know the space station, we know where all the handrails are, we know where our work site is so we can do the repairs or installations, whatever we need to do to make the space station better. Now, of course, it's different in space, but this is as close as we can get.
Today we're practicing some of the tasks and work sites that we might actually see on a spacewalk during our mission to the International Space Station. Although we don't know exactly yet what we're going to be working on, we train so that we're prepared for anything, whether that's planned or unplanned. It's so realistic. It's pretty amazing, this facility.
How much training do they get to do here in this facility before they actually go to space?
It's on the order of about 10 hours per hour of spacewalk. They spend quite a bit of time here. You have to get used to turning a bolt so many times or following the direction of the test conductor, just like mission control would do. A lot of training happens here before they even think about going out the door up there. Every time an astronaut gets in the water, we better prepare them for the most dangerous thing that they're going to do on orbit, and that makes them far more prepared.
Training can make the difference between a close call and a disaster. In 2013, Italian astronaut Luca Parmitano was on a spacewalk outside the ISS when water began leaking into his helmet.
It's hard to tell, but it feels like a lot of water. I see it now.
Water climbed past his nose, eyes, and ears. calm under pressure and quick action saved his life when he finally got back inside the station. NASA immediately suspended spacewalks to investigate, finding that the issue was in the spacesuit's cooling system. The incident led to critical improvements in spacesuit design and EVA safety protocols.
It takes a city to send somebody to space. We're just a small village off to the side. We help facilitate that training to get them out the door and doing their spacewalks.
We have most of the exterior of the space station, and of course we have facilities here at Johnson Space Center for training on the interior of the space station as well.
The vast majority of that training happens at Johnson Space Center. You go through mission-specific training with the crew that you're assigned to, and you go through your training, learning about all the things you are going to do, go through all the basic and emergency training, and then all the specific operations you're going to have on the flight. My first mission was STS-87, and it was 1 year before the space station launched. It was specifically a 16-day microgravity science mission. How to build a space station, how to build a truss. But a lot of it was just getting all of the experience we needed so that we could go into that wall of EVAs and make it through it.
The brilliance of the ISS lies in its construction, launching and assembling one module at a time over decades. Bill, you've been here since literally before day one. Take us back to day one.
You can see actually right here behind you is the first element that we actually launched the space station. That launched out of Russia in 1998.
Main engine start, 6 engines up and running.
And shortly after that, we launched Node 1, the Unity module, on a space shuttle.
We're ready today, and we're proud to be a part of building the International Space Station.
One element went to 2. That was the embryonic part of the space station. And they did some spacewalks because you had to connect a bunch of cables and hydraulics and fluid lines and so forth. And then when they departed, we had a space station on orbit. Now, no people were living on board yet because all the facilities weren't there yet. That was coming later.
Over the next 10 years, we worked to assemble this amazing spacecraft into what it is.
Over 42 assembly flights, 37 carried by U.S. space shuttles, and 5 by Russian Proton and Soyuz rockets.
The space station has changed tremendously over the years, from that embryonic 2 module.
You can imagine trying to put together an airplane while you're in flight. And we went through an early configuration where we were just set up for the basics, and then we completely rewired it and replumbed it while we were flying in order to get into this final configuration that we're in today.
Have you run into a lot of issues with the parts actually fitting when you get there?
We do have occasions where something just doesn't quite fit right. Most of the time, though, we've tested it on the ground.
And that was absolutely critical because once you get up there, there's no turning back. STS-104, now we're into the early phase of space station assembly, and we had to put up what's called the core. The core on the U.S. segment was the node, the U.S. lab, the Canadian arm. You would put a new piece on a space station having never actually physically verified that it would connect properly with the previous piece. And if you have a module out of the payload bay and you're trying to connect to the space station and it doesn't fit, a lot of times you couldn't get that module back into the payload bay and bring it home if it didn't fit. And then you'd end up with a $500 million paperweight up there.
How long did it take to get from that first launch in 1998 to fully functional with people living there?
The Russians launched another module called the service module, or Zvezda, which means star, in summer of 2000. And so now we had 3 modules. So that was key to being able to send a crew up there. The one thing that was still missing was some power. So we sent up a space shuttle to bring up the first set of solar arrays and some communications equipment. And once that was there, we could then launch the crew, the first crew, Expedition 1. And they were there for about 4 months. Their job was to make sure everything was working. And everything was working pretty well. Really was kind of rapid fire. And throughout the entire assembly process from 1998 to 2011, every single one of those pieces worked just perfectly. That I find is an incredible technological accomplishment.
Retired astronaut Susan Helms has spent 211 days in space and held the record for the longest single spacewalk, which lasted 8 hours and 56 minutes.
Mission after mission after mission after mission to the space station continued to bring up pieces of hardware that had to be added. The more capable it was, the more people you could bring up to live on the space station, and the more science you could bring up,
Between 2000 and 2002, I believe there were about like 12 shuttle flights, boom, 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 like every couple months, bringing up a new module.
The Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.
The shuttle was very key in performing all these tasks. It changed out the crews, brought up supplies, and brought up the new elements.
After I flew STS-121, became chief of the astronaut office. What I was responsible for is overall execution of all of the missions, making sure crews were assigned, make sure they were trained, working with Russia, negotiating who's going to fly on Soyuz. All this happened during the height of assembly. Crazy busy time because we were flying, training, flying. Every mission had some crisis on it that you had to deal with.
Run-of-the-mill challenges could be anything from a scrubbed launch to a damaged shuttle tile. Then in 2003, 17 years after the Space Shuttle Challenger disaster, a catastrophe occurred.
So we're going through assembly, building space station. In the middle of that, 2003, we had a space shuttle flight that was not a space station flight. It was on Columbia. They went up, 16-day mission, basically on ascent. Foam came off a place called the bipod ramp, put a hole in the wing, which nobody knew about till after the fact, and we lost them on entry.
At 9 o'clock this morning, Mission Control in Houston lost contact with our Space Shuttle Columbia.
Columbia, Houston, UHF comm check.
The Columbia's lost. There are no survivors.
These 7 astronauts were more than crew members. They were someone's child, husband or wife, father or mother.
You can kind of grip onto the technical of what happened, but it's more difficult to wrestle with the cultural reasons behind why it happened.
STS-107 was not the first shuttle flight to sustain foam and tile damage.
And that was hard to swallow for the NASA community to realize the organizational culture had probably gotten off track again. As Sally Ride said, echoes of Challenger for Columbia.
And so the shuttle was grounded for 2 years, so assembly kind of stopped.
That ground everything to a halt. We obviously had to figure out what happened, figure out how to get back to flying to at least complete space station assembly. Without the space shuttle, we could not have continued to assemble space station. We would have been done.
And because of the logistics flow, shuttles weren't bringing up food, clothes, and other items. We had to rely on the Russian Progress vehicles, which are much smaller.
So we had to actually take that space station crew from 3 down to 2, because that's all we could provide the logistics for. Meanwhile, on the NASA side, we were trying to figure out, okay, how do we get safely back to flight? We ended up with 2 return to flight test missions. The first one was STS-114, commanded by Eileen Collins, and I was moved from flight I was on to command the second one of those. And so between 114 and then STS-121, we were able to prove that and then continue with assembly and get to space station complete.
We're ready to go assemble station, and we're ready to start flying shuttles on a more regular basis.
Meantime, all these missions had gone on and all these other elements had come up. The European module, the Japanese module, the cupola, which is really cool with a bunch of windows, an additional node, node 2, and then we went from 1 solar array to 4 giant solar arrays. STS-133 was my last flight. It actually was the last module that the US put up on space station. And when I saw it during rendezvous, I looked at it, and as I got closer, it was way bigger, just huge compared to the last time I'd seen it. So I feel very fortunate to be able to see space station in its infancy all the way to the end where it was fully complete. It's pretty much today as it was when I left it in 2011. The space station assembly, what we're doing, a space station and space shuttle, is by far the most complex thing we've ever done.
By 2011, construction was finally completed on the International Space Station. Focus could now shift to research.
Now that we've finished building the space station, we've really hit our stride in using the space station for research and for science and for technology demonstrations, commercial applications.
Bigger than a 6-bedroom house, the International Space Station is a marvel of engineering, with 6 sleeping quarters, 2 bathrooms, a gym, and a cupola observation module offering a breathtaking 360-degree view of Earth. The station's electrical power system is linked by over 8 miles of wiring. Up to 8 spacecraft can dock with the space station at the same time, bringing supplies, experiments, or new crew. This facility is where the astronauts come to train inside the ISS.
We have almost an entire space station in mock-ups on land, gave them all kinds of ways to train and simulate before we actually went and did the real thing.
We are heading into the Japanese experiment module, otherwise known as Kibo. This is one of the laboratories that we have on board the International Space Station where we can do a variety of research.
Right now, we're in the Japanese laboratory. It's one laboratory out of many here on the International Space Station.
We don't have to worry about gravity when we're up there, so we put things all around. You can see here we have a glove box. Sometimes you got some stuff you need a little bit of extra containment on, and this allows us to do experiments that enable that. You can imagine there's 7 people up here all the time working together. And when you get into that space, you kind of need your own space at times, and then you need enough space for somebody to come help you out.
Humans aren't really meant to live in space.
There are a lot of things that we have to work through just to keep people alive that we take for granted on the ground. Finding a space to create oxygen, remove carbon dioxide, just finding a place to sleep. In fact, we can go this way. I can show you where the crew sleeps on board the space station.
Ooh, let's go check it out.
In here, this is where they sleep. And you can imagine all the other daily functions that they have to go through are located in various spots around the space station. You have your bedroom, you have your closet, you have your kitchen. We have an exercise space where they have to stay healthy because you can imagine in microgravity, your muscles aren't working hard. So we study that on board.
We would typically use the space station mock-up to do things like day in the life. It gave you a sense for operating in the space station.
They're going on a 6-month camping trip up here. We've learned how to better prepare them for that.
Even learning something as mundane as how do you prepare food? How does the toilet work? Everybody jokes about the toilet, but that's a critical piece of equipment.
On space station, one of the first things that would happen when you get on board, if you were used to flying on the space shuttle, you'd go, wow, this is big. I could live here a long time because there's a lot of space. Then you'd find your sleep station. You'd basically spend time outfitting your nest with your stuff. We would all wake up at 6 a.m. by the clock, and we would all go to bed at 10 p.m. by the clock. But there was a lot of times during the day where we had to decide how we were going to get things done together or apart, washing our hair, cutting our hair, using a vacuum cleaner that we had in order to vacuum up the trimmings of the haircuts. And after I saw the results, they asked me if I wanted my haircut, and I was like, oh no, I don't think so. You guys, keep your day jobs. You're not necessarily hairdressers. The ISS has taught us that we can do this. Humans can actually leave the planet and exist as humans. I wouldn't have said that about a shuttle mission. It was not realistic for humans to live that way for months at a time, but on space station, you can see how it could be.
We'd launch with a 14-day flight plan. I guarantee you by flight day 2, the rest of that flight plan, you can throw it away. You really work as a team. The flight director even starts working the mission before the crew does. It's a critical operational team. We couldn't fly without them.
So this is the flight control room, and it's led by Anthony Varia today, who's the flight director on console, and everyone will work a 9-hour shift. We have 3 a day with about an hour of handover in between. So all these people together build up technical disciplines and specialties which collectively make that team to be able to get things done, to be able to solve problems where they happen, to be able to plan spacewalks and launches and rendezvous and dockings and so forth.
So we have to keep it down because the guys are working on some real-world operations.
The flight control team is constantly watching all the systems on the space station, and so at any given time, they're watching our temperatures in the right range, are the pressures looking good, they have to process water, they're generating power from the solar rays and so forth. So if anything goes wrong or if they see any signatures, they have to diagnose what sort of issue may be going on.
Mission control was actually created so that you could have a team of people on the ground that were looking and monitoring everything you could about the spacecraft in the level of detail that a crew on board necessarily can't. The flight director directs the activities of the flight. The crew executes the flight requirements. Doing something complex and pulling it off. To me, that's the reward of space.
This is a vehicle that has brought countries together to accomplish something just enormously difficult. During some of the most challenging geopolitical issues on the surface of the Earth, we have to work together up in space. That is, I think, something that has taught us how to work together as humans, as all astronauts on this planet Earth.
The International Space Station is more than a spacecraft. It's a classroom, a research lab, and an unprecedented engineering feat made real by engineers, scientists, and astronauts from around the world.
We keep having joint crews up there, doing research together, eating meals together, celebrating holidays together. I only see that as a great example for future programs where we will have international collaboration.
We've had continuous human presence up there since the year 2000. We learned a lot about what to do, and we learned a lot about what not to do. I think it will always go down as one of the great engineering marvels.
Not only have we demonstrated our ingenuity, we've demonstrated that we can do it as humanity.
By 2030, NASA plans to begin the process of deorbiting the station, saying goodbye to a legacy over 30 years in the making. But what it gave us, the science, the diplomacy, and experiences living in space will inform humanity's next journeys into the cosmos. What we learned on the ISS will shape how we travel to the moon and how we survive the long journey to Mars, and maybe, just maybe, how we live beyond Earth. We'll see you next time on Behind the Wings.